We're going to do all this stuff. We're going to do association, and we're going to do composition. We're going to review the stuff we did last time. Right? So we introduced these new notations on top of our UML class diagrams last time. We had classes, and then we had these funny lines, and we numbered them, and we put stars and things. And so we're going to go over that again. We're also going to go to talk about equals method and equals equals. So there's kind of two ways of doing object equality in Java. And we're going to go over each one because they're significant for your project. Right? So those are really important because there's already questions coming up on Piazza about those. So you really need to know those before you can finish the project. And then I'll do a little SVN demo between two computers. And hopefully all of this magic technology will work just fine. The punchline there is that you should always synchronize with the repository. Okay, that's your first step when you're working with your partner. And then we're going to do a little bit of data structures work in trying to implement association and composition. And then on Monday, we're going to have a lecture lab, and we'll talk about hash code and mapping data structures. Great. So let's come back to this diagram. So this is what we did last time. And we introduced this new funny notation, right, where we, down below this rectangle and circle, they're just subtypes of figure. Right? So this is a very standard relation that you all know about. And then we introduced association and composition. So composition was this straight line. It might or might not have errors on it. And the straight line has numbers to indicate the number of objects that you're actually talking about. So there's a 1 here next to a drawing editor. And this 1 indicates that a tool knows about exactly 1 drawing editor. So you read these kind of down from the object up to the second object. So you say a tool knows about 1 drawing editor. And then you say a drawing editor knows about 0 or more tools. Okay, so I'm going to read that down. So this is an association. It just says that your instance of one of these types, your object, must have references to these other objects. And we're going to actually try to implement these in code. Now, the second relationship was composition. And composition is a little bit strange because it differs from association in a very minor way. And the way to think about it is that wherever this funny diamond is located, this is the hole. If you can read that. So that's the hole. And then wherever it's pointing to, that's the part. So a drawing is made up of multiple figure instances. And you know it's multiple because you can read it down and you say, a drawing knows about multiple figures, 0 or more. That's what this notation means. So this is a part-whole relationship. And the most kind of distinguishing feature of this relationship is that this figure, in some sense, is owned by the drawing. So you cannot have a part be of multiple wholes, in other words. So what that means is that if I want to make some change to a figure and I don't have a reference to it, I can't just directly talk to it. I have to talk to it through the drawing. Okay, so typically it doesn't make sense to have another associative relationship to something that is a part of a whole. Right? So you wouldn't have this. You would have X talking to drawing in order to reach figure. Okay, so there's an ownership relationship as well. So the drawing, in some sense, owns the figures that it's made up of. You guys have any questions about associative compositional relationships? Completely clear? So let's try to implement this thing in code. And then the second thing we'll do is actually try to model just like an arbitrary system that we'll come up with on the fly. Okay? So the code part of this is the figure drawing starter, which is in your lectures lab. Anytime now. So this project doesn't compile. And doesn't compile because these relationship, the association between drawing and editor and tool, drawing editor and tool, drawing editor and drawing, drawing and figure are not implemented. Okay, so we need to fill in the details. So the process that you go through in order to fill in the details is approximately as follows. So you first have to say what relationship you want to implement. Okay, that's like step one. Then I have to figure out what data structure I'm going to use to represent the relationship. So you can start with this one. So this drawing knows about multiple figures. So let's focus on this relationship. So I'll go to my drawing. And here it is. Here's my class drawing. That's my realization of this model, right? So for this thing to truly reflect my model, it needs to have this relationship. And what that means is that my drawing needs to have a field that represents multiple figures. And so now I have to think about what is going to be the type of that field. What data structure do I want to use to represent multiple drawings? Right, so I'm going to declare something here now. It might be private, some type, figures. So I have to figure out the type. So if we have multiple figures, how do we store multiple figures? What would you use? Set and list, right? So for this course, you really need to know about just two data structures, sets and lists. So for figures, which one makes most sense? Who said set? Why did you say set? Okay, next person. Who said list? Why did you say list?
Because we can have multiple of this.
We can have multiple of the same figure. That's interesting. So if I wanted my drawing to support kind of like copy-paste operations, right, where I replicated the same figure multiple times in the drawing, then a list makes sense, right? Because I don't need uniqueness. So I would use a list. You would also use a list if you had a specific order in which you needed to draw them, for example. Right? Maybe there's a sequence in which you actually drew the figures in your drawing, and so you would use that sequence. You would store that sequence. But it largely depends. There's like, my model doesn't tell me, so I have to figure that out. So it's up to me to figure out how I'm going to realize this. So I can say it's a list. So what is my list storing? Figures, right? So I'm going to use this funny notation where I have these brackets, and in the middle I'm going to say figure. So far we've been telling you to ignore these things, but you're going to keep seeing more and more of these. So these guys are essentially parameters to my data structure. So if I were, if I were to look this up online, let's say I find list, Java, and here's my documentation for list. So my documentation for list tells me that it's an interface, right? So I cannot create a list, but it's a type in Java lang, Java util. But it's parameterized with something that looks like an E. And this E really stands for element, and it could be any type that I want. Okay, so when I create lists, those lists contain things. And if I create a list, I want it to contain the same kinds of things. So this E that I get to choose, right, is going to represent the sorts of things, the types of things that will be in my list. So when I'm declaring a list here, my figures is going to contain figures. So the type of the objects that it will contain is figure. And I could make this anything I want. It could be double, right? I could just have a bunch of numbers. I could have a bunch of strings. So I'm changing the underlying type of the things this container will have. And in this case, the type will be figure. Okay, so just think of this notation as another parameter to my data structure, list in this case, that tells the data structure what sorts of things it will actually store. Okay, so we have this relationship now. We implemented this part where my drawing knows about multiple figures. So what about figure? Does my figure know about my drawing? It doesn't, right? So I have this arrow. This arrow indicates that my drawing may refer to my figures. Obviously, it needs to know about its parts, right? But this arrow is one way, so my figure doesn't know about my drawing. So as far as I'm concerned, from an implementation point of view, this is done. I'm finished with this relationship. So let's do the second one. Let's do this associative relationship between drawing editor and drawing. So I choose that relationship. I'm going to go to, I don't know, let's go to drawing editor. So my drawing editor, an instance of a drawing editor, knows about 0 more drawings. Okay, so again, I have to say, I'm going to have some number of drawings. So I'll have private something drawings. So what about now? What should be the type of drawings? You really have just 2 options, guys. You can just scream it out. Yeah.
List drawing.
List drawing. Who thinks a set would be better? Why set?
Because you don't have repeated drawings. You wouldn't want repeated drawings.
Yeah, it's a drawing editor. Maybe it doesn't make as much sense to have multiple identical drawings, right, in the drawing editor. Who thinks it's a list? Why do you think it's a list?
There was the word drawings in there.
Yeah. Okay, let's make it a set. Sorry. Hey, I get to implement things, not you. All right, so it's going to be a set, and it's going to have a bunch of drawings in it. So I probably have to import my set. So again, it's the same thing, right? It's a container. I'm parameterizing the container. I'm telling it that the sorts of things it expects are drawings. So that takes care of one side of this relationship, where a drawing editor knows about multiple drawings. Now I need the other side. I have to say that a drawing knows about exactly one drawing editor. Right, so I have to implement the reverse. So I have to go to a drawing. Let's take a look at it. So a drawing, very similar. It's initialized. Its constructor takes a drawing editor, but it doesn't do anything with it right now. So all we need to do right now is cache it. Lucas, you have a question? Okay. So what do? I create a new field for the drawing editor. So I'll create a field, private drawing editor. So when you implement these relationships, right, the sequence of steps is like, well, you're not going to see any of this. So it's like choose relationship, create a field. And by create, I mean declare it at the very top. And then I have to choose a data structure. I need to choose a type for that field. And then the last step is actually to initialize the field. So just because I declare it here doesn't mean that it's actually holding any object. So in the other cases, there were already statements that would add things to those lists. But here I need to add this. So I would say something like this dot editor equals ed. So this statement initializes editor to be ed. So now I'm actually using that field, and I'm storing the reference to my drawing editor from within my drawings. Okay, then the final relationship, you can't really see it right now, but you have drawing editor, and drawing editor needs to know about multiple tools. Okay, so I have to do something very similar. I'm going to say private tools. So what about now? What data structure do I use? Probably set, right? Because if I have multiple tools in a list that are the same thing, it doesn't make sense. So I need a set. It's parameterized. If you just leave it like this, it won't compile. So you must tell it what it's going to hold. And it's just going to hold tool objects. Okay? So I'm going to build my project. And I have things that don't compile. Let's see what's not compiling. So here's a great example of how we do some debugging. So I have a bunch of compilation errors, right? And my compilation errors all have to do with this editor. So I'm using the field editor, and I'm using it within the tool subtypes of tool. And the error that I'm getting is this editor thing doesn't exist, cannot be resolved. What do you guys think is the problem? So I have tool, I subclass tool to create a bunch of tools. Oh, that's awful. I need like a giant marker. So I have these move tool, I have an oval tool, and so forth. Maybe this will help. No?
Because the editor is inside of the drawing method.
The editor is a field. A field belongs to my superclass, my tool, right? So if I go there, F3, here's my tool. Oh, look, I don't have an editor, right? So that's probably was the problem, right? I implemented only half of this relationship. So my drawing editor knows about multiple tools, but my tool doesn't know about my drawing editor. Okay, so that's what I'm missing. So I need to declare an editor in here. Okay, so let's say I declare private. It's a drawing editor. I save it. Okay, what's happening now? My things are still not compiling. And what does it say? The field tool editor is not visible.
It is private.
Yeah. So the problem is that my tool knows about a drawing editor, but it's encapsulating it. It's keeping it private to the class. So the subclasses do not know about drawing editor, about editor. So how do I reveal it to just the subclasses? Protect it, right? So the visibility scope that I actually want is protected. So you could use public, but public would actually reveal this thing to everywhere, to the entire world. So when possible, try to make the scope, the visibility scope, as confined as possible. Okay, so in this case, protected is actually sufficient. Hopefully. If I build the project, it compiles. Yeah?
Don't you call it into the constructor?
Do I need to call it in the constructor? That's a great question. Editor, yes, I do need to call in the constructor. So I need to say this.editor equals editor. Thank you. So right now I'm compiling my project. Look, my project compiles. Doesn't mean that it works, right? So there might be a bunch of initialization statements that I'm missing. Maybe there's other issues. So not initializing it is a runtime error, right? It's not a compile time error. So that's why we didn't see it as an error. Other questions? Great. So the kind of the high level perspective that you should have is you're given a diagram like this for the project. And actually, I have it somewhere. So here it is. This is what you need to do in the project, right? So you're doing something very similar. You're creating classes for each of these boxes. You're putting a bunch of stuff into those classes. And then you have to relate them, right? You have to make sure that these relationships, associative, relationships, there are no compositional ones here, right, are respected. So you have to implement those in the same way that we just did. So you look at a relationship, you say, okay, this is one-to-one or many-to-many. So I need a list, or I need a set, or I just need a field of that one type element. Right? I create that field, I'm going to initialize that field, and then I'm going to use that field in some way. So that's what you need to do in the project. Okay, so the second thing we're going to talk about is about equals and equals. Wow, that is awful. Maybe I'll just use the whiteboard today. Let's use that. So let me actually demonstrate this with this example. So I have a tiny class called course. So this class, wow, it's so huge. This class represents a course, like at UBC. So a course has, it's in some department, so it's associated with a string called department, and it has some number in num. So I can create a new course. I initialize these fields. I can print out this course. And this is where I use the toString method to override the typical toString. And then at the very bottom, I have a tiny program. And the program is going to create a new course. It's going to print out what this course looks like. Create a second course. Print out what it looks like. And then it's going to first evaluate try equals equals to determine whether the two courses are equal. And in the second half, it's going to try dot equals to determine if the two courses are the same. So that's the program. So notice that the courses I'm creating a course object with department CPSC and number 210. And then I'm creating another course project, CPSC, and number is 210. So in a sense, what I did here is I have course 1, and it's a variable. It's a variable that's going to refer to a new object. So this is a course object. And the course object contains the string CPSC and then 210. So that's what that first line of code is doing. And then my second line of code says, well, I'm going to have a second variable, course 2. And my course 2 is going to refer to an object. So this is a course object as well. And it's going to have the same string and the same number. Okay, so that's kind of what you should have in your head when you're looking at this code. I created one course, and then I created a second course. Is the whiteboard any better? Can you guys see it from back there? Okay. Okay, so now I'm doing equals equals. So when I say course 1 equals equals course 2, what do you think is going to be the result? Is that going to be true or is that going to be false? Say it louder. I heard some truths in there, I swear. Why is it false? All right, so course 1 equals equals course 2. What is it doing? It's comparing this object to this object. But it's really comparing them in terms of, are they the same object? Right? So they're not the same object. Because look, I drew two different objects, right? They're not the same object. So when you have two distinct objects in memory, like course 1 that I created with the keyword new, and course 2 that I created with the keyword new, those are two separate objects in memory. So equals equals should return false. So hopefully this will be true, right? They'll print out this line. Okay, what about dot equals? little trickier. What happens with dot equals? Is it going to be true or false? How many think true? How many think false? Wow, okay. Let's see what happens. So I'm going to run this thing. Save it. And my output, voila! My course 1 is not equals to course 2. And my course 1 is not dot equals to course 2. All right, so no one got it right. Perfect, so there's something to learn. So what's the story? Any ideas? Why?
You have to overwrite the equals method in order to tell it what is actually being compared.
Right, so the response is that I need to override dot equals. So here's a little observation. So if I look at my course class, this is all of it, right? My course class does not have a dot equals method defined in it. It's not there. So what's going on? What method am I calling? Object method, right? So the perspective that all of you should have when you see a class, let's try blue, is that there's a class inside of Java, and this class is called object. Yeah, it has some fields, it has some methods. And then whenever you create a new class in Java in your project, you're always by default subclassing this object class. So when I create a course, my type hierarchy actually looks like this. So when we drew all of these type hierarchies, we're sort of lying to you, right? Because we've always omitted object. The reason we've omitted it is because this is implicit. This is implied. Okay? This is always true for any class you create. Okay, so if my equals method is not in here, then thinking about just inheritance that you guys know about, my equals is actually in there. Okay, so this object class defines a couple of methods. And so one of them is an equals method. So actually, it's going to take an object. And then the second method here that you should know about is toString. So toString generates a string representation of an object. So let me show you the example with toString. So I actually overrode toString here, right? So I can remove toString. And notice that when I'm printing out the courses, I'm using the toString method. And it still compiles. So toString must exist. It must be in my superclass, in object. So if I run this code, then my output looks like this. You've probably seen some of these. So here's my standard toString method on the course object. It just prints out course, and then it prints out a bunch of garbage. Well, not really garbage. It's really the memory location of that object. So this default method is implemented, and the default method prints out, here's the string representation of your object. So if you wanted to change the string representation of your object, then you would override the method. And that's what I did here. So you'll add another toString, you'll override it, and then you'll return the kind of string representation that you want to use for your course. So if I save it and run it now, then my representation is going to be as follows. It's much nicer, right? Print out the department, print out the number. So that's toString. So the same story is going to be true for equals. So my equals is currently not defined. So it's using some default version of equals that's located in an object. Anyone want to guess what that default version of equals do? Does equals, right? So if I don't override dot equals, it behaves exactly like equals. So it's actually just going to compare the object instances. Just going to say, are they pointing to the same memory location? So that's why my dot equals doesn't work on these two courses. But if you think about it, right, from a modeling perspective, if I have two courses and they represent actual two courses that have the same number and they're in the same department, they have to be equal, right? So this kind of default dot equals behavior is not what I want. So what I'll do is actually override dot equals. But the only problem is that if you look at, so here's a class object on the Java documentation. So you can actually find out all of these methods and fields that an object, supertype, in Java creates, right? So it has a bunch of methods, not that many. So here's its toString, and here's the equals. So it's a really long description of equals. So my equals needs to have certain properties. Remember invariants, right? Requirements, specifications, right? So in some sense, this is a specification of what a proper equals method should do. So it needs to be reflexive. It needs to be symmetric. It needs to be transitive. It needs to be consistent. It has a bunch of requirements. So in practice, it's actually quite challenging to override equals. It's very easy to make a mistake. So that's why we're not going to write it from scratch. We're actually going to use Eclipse. So Eclipse has this very handy feature where I can right-click on my code. I can go to source. And I can just generate my equals method. It's going to be very magical. This is like the biggest cheating thing, right? Don't do this on the midterm. I'm kidding. You should totally do this on the midterm. This is what I would do. Your hash code, so equals, I should mention there's this other method called hash code. Hash code is also inside of object. We're going to talk about it on Monday. The two methods always go in pair. You can't define equals without defining hash code. You cannot define hash code without defining equals. Right? So today, we're just going to kind of blithely ignore what hash code does and generate the default equals. So if I click on this, it's going to give me back a little wizard. And this thing is going to ask, OK, so you want an equals method. What sort of things should you compare in your equals method? So I can only really think about fields, right? So my default kind of behavior here is that it lists all the fields in my course, which has a department name and then also the number of the course. And then I get to check or uncheck the ones that I want to be included in my equality check. So for the courses, I want both. So in order for the two courses to be equal, the department has to match and the number has to match. So that's why I'm including both. Click OK. Look, I have way more code now. Wow, it had to create all this beautiful Java code for me. I didn't have to do it. So what does this thing do? So there's kind of a standard template to writing .equals method, which is why it's possible to actually do this. So at the very top, you see that equals takes an object. So it takes an instance of this very, very abstract class. So it can be anything, right? It could be a sax parser. It could be a course object. It could be anything you want. And it tries to determine whether that object is the same thing as the object that is being invoked here, right? Where equals is located. And it's going to return true or false, whether the two are equal or not. So the first step is to say, well, if it's if it's equals, then return true. Obviously, if they're pointing to the same object, then they're the same. So if I have course 3, right? If they're equal, then there should be .equal. I hope you're able to parse that. So this equal object, right, implies that this .equals object. And then the second thing says, well, if the object that you gave me is actually null, it's pointing off into space, right? If course 3 actually just points off into space, then obviously they're not equal. So that's what this thing does. And then you have a line of code that says, well, if the classes of the two objects are different, then they're not the same. So if I know that course 3 points to something called Zax parser, hey, Zax parser is not a course, so don't even bother checking them. And then finally, at the bottom, this is where the really cool stuff is. So here I'm actually saying, well, an object, okay, fine, I'll treat this object as a course. So this is where I'm performing a cast, right? So I'm going to treat this object as a course, and that's going to be my other instance. And then I'll check my department, and then I'll check my department in this block, and then I'll check whether the number of the courses match. So it's doing all of this stuff for you, okay? So now if I run my code, my output is going to be, well, the two courses are not equals equals, but they are dot equals, which is exactly what I want. So it allows me to compare courses, compare objects now in my implementation. You guys have any questions about this whole equals thing?
If you said that the classes were static, would the equals stay true?
Well, we didn't cover static, so you don't have to worry about it. Yeah. Other questions?
I was wondering in the lab, when it says that you have to, whenever you override the equals method, you also have to override the hash code method?
That's right.
Or how come, like if you're overriding the hash code method, doesn't that mean that you can just keep the old equals method because you can make the hash code equal to whatever you want it to be?
No. So hash code and equals, there's a requirement about consistency between the two. So if your hash code, let's put it this way. If your dot equals returns true for the two objects, then your hash code must return true for the two objects. So there's an invariant between hash code and equals.
So the hash code method is just checking if the two hash codes are the same?
So think of hash code. Well, hash code is used for different things. The way you're going to use them, we're going to use them in class on Monday, is to use them in maps. So hash code, in some sense, is an optimization on top of equals. Hash code allows me to assign a bunch of objects to a bin, right? So assign the first row to bin first row. Assign the second row to bin second row. Okay, so it's kind of like this. You can think of it as a course equals method. So it's an approximation for equals. But it must respect the fact that when you have dot equals true between two objects, then hash code must be true between the objects. So if two students are in the bin for same row, then they must be in the same row.
So is it that if they're equals, then their hash codes have to be equal, but is it not necessarily the same in the opposite direction?
No,
Okay.
the opposite is not true. Doesn't have to hold.
Okay.
Jane?
In line 34, why we need to create another?
In line 34, why do we need to create another course object? So my object here is an object type. So I'm going to cast it. I'm going to represent object as a course. So this is a cast, and it creates a new variable. So the way to think about it is if I'm comparing these two courses, and I'm saying course 1 dot equals course 2. Right? Initially, this course 2, it doesn't know that it's a course. So it says, oh, it's an object. Okay? But when I cast it, it says, well, actually, it's not an object. I know that it's a course. Okay? So that's what that cast does. It essentially says, well, it's not an object. I know that it's a course, so I'm going to treat it as a course. So it's changing, in some sense, it's changing the parent type, right? The parent type of obj is object. The actual type of obj in that statement is course. So I'm pulling the parent type down, and I'm saying, actually, the parent type is course. So that's what this operation does. Okay, I need to cover one more thing. And that's the SVN demo. So hopefully this will work. So in your project, you need to work with a partner. And you're going to be using the same SVN repository to do all your work. So coordination in SVN is a little bit tricky. So that's what I'm going to show you. So I have 2 Eclipse windows. Which way is it? Oh, it is this way. Oh my God, that's going to be so hard. OK. So I have 2 Eclipse windows. And they're editing the same file. So this is like you and your partner, right? So we're working on the same project. We're going to commit to the same repository. So you have to follow certain rules in order for that to work out. Because it's very easy for you to delete the code of your partner. In which case, you have a sad partner relationship, and then you divorce for phase 2, OK? So you don't want that to happen. And we don't want to deal with that. So great. So how does this work? So notice that the 2 files right now, they're identical, right? So let's say I'll make some changes here, like my changes in class. I'll save it, and I'm going to, first, I'll do team, and I'll synchronize with the repository. So this is the first thing you should always do in SVN. This grabs changes from the server and then compares them to my local changes, and doesn't at all affect my files. So I'll synchronize with the repository, and this will bring up this team synchronization perspective. And it says, look, there's this little arrow, and it's an arrow pointing to the right, which means that I have changes that the server doesn't have. OK, so at this point, I can try to do team commit. And I'll create a little message that's helpful for my partner. So I'll say, changes I made in class. Wow. OK. So off they go. They go to the server. Right? So I made the changes. This window, still not updated. Right? So this person keeps working, and they're like, OK, maybe I should see what Ivan did in class. So the step here is to right-click, and then go to team. And very similarly, go to synchronize with the repository. So this arrow is pointing to the left. I don't know why. But it basically says there's stuff on the server, and I need to look at it. So if I look at the changes here, if I double-click on that file, it's going to say, look, there's changes that are local. That's just changes A. And then I have changes that are at the server. Those are the remote. So now I get to decide what I will do. Do I keep my local changes and throw away what's at the server? Do I commit my local changes? What happens? Okay? So all of those operations are available to you. And in this synchronization kind of step, you have to choose one of the options. Okay? So one thing that I could do is I could say team, and I can do update to head. So when you do update to head, that means grab the latest versions from the file, from the server, and then replace my version locally with the version on the server. Okay, so you should be really careful with that operation because it'll replace whatever you have. So always synchronize first to know what's on the server. And make sure that you want it. So I'll update this thing. And now I have no changes. If I go back to Java, and here it is, right? My file was updated with changes in the class. So my changes from this computer went to this computer through the server by following a strict sequence of steps. And the most important of which is that you should always synchronize the repository before you update. So this is all under team synchronized with the repository. OK, so that's a quick overview. We'll see you